You know when you order something online, you click buy, and then almost instantly, everything just happens. A confirmation email hits your inbox, your card gets charged, and somewhere in a warehouse, your stuff starts getting packed. How does all of that happen at the same time without some giant central brain telling everyone what to do? Well, today we're diving into the magic behind that. We're talking about event-driven architecture, and specifically a really powerful style called the broker topology.
So to really wrap our heads around this, we first have to make a little shift in how we think about software. It's all about moving from a world of requests to a world of events. They sound similar, but they are fundamentally different. On the one hand, you've got the traditional request-based model. Think of this like asking a direct question. Hey, show me my order history. You ask, you wait, you get a direct answer. It's synchronous, it's predictable. But on the other hand, we have the event-based model. This is way more like an online auction. You don't command the system, you just do something. You place a bid, and the system reacts to that event. It's asynchronous, it's dynamic, and it's a much more fluid way of doing things. Okay, so now that we've got that core idea down, let's pop the hood and look inside a very specific and super popular style of event-driven architecture, the broker topology. It's time to meet the key players that make this whole thing work.
The big idea with the broker topology is one word: decentralized. There is no central boss, no single orchestrator calling all the shots. Instead, you have all these independent components that just communicate by passing messages through a shared channel, kind of like a digital post office. Every part of the system is autonomous. So, any system built this way really boils down to these four core components. First, you've got the initiating event. That's the spark that starts the whole process. That event gets sent to the event broker, which is our central post office. Then, an event processor, think of it as a specialized worker, sees the event, picks it up, and does one specific job. And finally, when it's done, it announces its work by creating a brand new processing event. It's a simple loop, but it's incredibly powerful.
All right, theory's great, but honestly, seeing this in action is way better. So let's follow the journey of a single online order from start to finish. This is where it's all going to click into place.
Okay, picture this. You're on a website, you found what you want, and you hit that big Buy Now button. That click, right there, that's our initiating event. In the system's language, it gets packaged up into a neat little message called Place Order. And bam, it's sent off to the event broker to kick everything off.
So who's listening? The first component to perk up its ears is the order placement processor. Its job is super focused. It hears the place order event, goes and creates an official order in the database, and then importantly, it shouts back into the system what it just did by creating a new event called Order Created.
And right here, this is the magic of the whole system. That one Order Created event gets broadcast out, and check this out. 3 totally separate independent processors, notification, payment, and inventory, all hear it at the same time, and they all start working in parallel. One is sending you an email, one is charging your card, and the other is updating the warehouse stock. They have no idea the others exist, they just react to the event.
Now, let's follow one of those threads. The notification processor does its job, sends the email, and like a good little component, it announces its work by sending out an email sent event. But here's the funny thing. Right now, nobody cares. No other component is listening for that specific event. It's just shouting into the void. Kind of weird, right? Seems like a waste of energy. Well, it turns out this isn't a bug. It's one of the most brilliant features of this architecture, and it's called architectural extensibility. By broadcasting events even when no one is listening, you're literally creating hooks for the future. So 6 months from now, when marketing wants to track email open rates, you can just plug in a new component that listens for emails sent. You don't have to touch any of the existing code. It's like future-proofing your system by design. Okay, so far we've been living in a perfect world where everything works. But we all know, real life is messy. Things go wrong. So let's ask the really important question. What happens if the customer's credit card gets declined? How does a system with no boss handle failure? And the solution is just really elegant. The payment processor has 2 possible outcomes. If the payment goes through, great. It sends a payment applied event. The order fulfillment processor hears that and starts packing the box. But if it fails, it sends a totally different event, payment denied. And guess who's listening for that one? The notification processor, which immediately sends an email to the customer saying, hey, you might want to update your payment info. The workflow just branches naturally, all guided by the events themselves.
So we've gone through the mechanics, but what's a good way to keep this all straight in your head? Well, there's a fantastic analogy for this that makes it all crystal clear. Just think of it like a high-speed relay race.
Yeah, this quote from the source material absolutely nails it. In a relay race, what does a runner do? They grab the baton, they sprint their leg of the race as fast as they can, and they pass the baton to the next person. Once they've handed it off, their job for that specific race is over. Event processors are exactly the same. They do their one job, they create a new event, the baton, and they pass it on. They're not worried about the finish line.
This all sounds amazing, right? It's scalable, it's super responsive, it's decoupled, it seems like the perfect solution. But, and this is a really big but, like any powerful tool, it's not a silver bullet. It comes with some pretty significant trade-offs that you have to understand before you even think about using it. And here they are, laid out side by side. On the one hand, the benefits are huge. You get components that are highly decoupled, which leads to amazing scalability, responsiveness, and performance. But look at the other side of the coin. You give up any kind of central workflow control. Handling errors gets a lot harder, and there's no easy undo button to recover a failed transaction. You're making a deliberate trade. You are sacrificing control for speed and scale.
Let's just zoom in on those challenges, because they are so important. First, no central control. That means no single part of your system actually knows the full story of that customer's order. Has it shipped? Did the payment fail? Nobody knows the whole picture. That leads right to problem number 2, error handling. If that payment processor fails quietly in the background, the order could just get stuck in limbo forever, and nobody would even notice. And that brings us to recoverability. You can't just restart the whole order because other parts of the system have already done their jobs and moved on.
So where does that leave us? The broker topology gives you incredible power, massive scale, and lightning speed by basically embracing a kind of organized chaos. It intentionally gives up central control in exchange for extreme flexibility. And that leads us to the ultimate question every architect has to ask when they look at this pattern. When is the chaos worth it?